Another type of loop used in Java frequently is the for loop, which can often accomplish the same task as the while loop in less lines of code. The way a for loop works is it first executes the first statement in the parentheses. So inside the parentheses, there's 3 statements. The first one, it executes it only once. Then afterward, it checks if the condition is true, like the while loop. Then if the condition is true, I execute the inside. Then afterward, I execute the third statement, which, by the way, doesn't need a semicolon. So in this case, I is set to 1, then 1 is less than or equal to 100, so it prints 1. Then afterward, I becomes 2. 2 is less than or equal to 100, prints 2, and so on until all the way up to 100, as shown below. And this for loop works in the exact same way as this while loop would work. Int I equals 1 only executed once, then while I is less than or equal to 100, print I, then I++. These 2 pieces of code are identical, except the for loop is slightly shorter. Another thing that makes for loops more convenient than while loops is the fact that I could reuse the same variable name over and over again. So for example, for int I equals 0, I is less than 5, I++, just do something, print it. Then I can copy this piece of code, and I is reused, but because it's declared inside the for loop, it disappears outside the for loop. So I can copy this as many times as I want, and it would work properly, because the variable is technically not reused due to the fact that it disappears. I cannot do this with a while loop because the variable is declared outside, which means it doesn't disappear. Here's another example. Print the even integers from -36 to 48 inclusive. So basically, we use a for loop starting from -36 going up to 48, then adding 2 each time to ensure it's always even. Then afterward, printing it inside the for loop. And it works. Another example, print the integers from 0 to 100 inclusive that don't have a units digit of 7. So the way we would do this is first we just do a normal for loop, go from 0 to 100, and this time there's no way to easily skip around, so instead we use an if statement. So if I%10 is not equal to 7, then print I, and then we're okay. Another example, print the sum of the integers from 1 to 100 inclusive. So this time, again, we go from 1, we go up to 100. However, this time we need to make the sum variable outside the for loop, and the reason of that is because if we make it inside the for loop, then we can't print it on the outside. So sum plus equals I, then system.out.println sum, and then it works as shown below. Here are a few exercises. So the first one, first I equals 0. 0 is less than 10, so it prints 0. Then I becomes 2. 2 is less than 10, so it prints 2. Then I becomes 4. 4 is less than 10, so it prints 4. I becomes 6, prints 6. I becomes 8, prints 8. Then I becomes 10. 10 is not less than 10, so it doesn't print 10. It exits the for loop, as shown below. Next exercise. So this one, first I is initially 10. 10 is at least 0, so it prints 10, then I plus plus. If you remember, I plus plus means it first does the statement, then it does I plus plus. So then therefore, then I becomes 11. Then I minus equals 2, so now I is 9. Then prints 9, I becomes 10. Then I becomes 8, prints 8. Then I becomes 9, then I becomes 7, prints 7. I becomes 8, then I becomes 6, prints 6. Then prints 5, 4, 3, 2, 1. I becomes 2, then I becomes 0, prints 0. Then I becomes 1, then it becomes -1. -1 is not at least 0, so then we're done. As you can see, it prints 10 through 0, basically 0 through 10 backwards. Next exercise. So I starts from 15, then 15 is at least 0, prints 15. Then I becomes 16, prints 16. I becomes 17, prints 17. I becomes 18, prints 18, and so on. Because it's basically an infinite loop. I is not going to become less than 0 because I'm increasing I every time. So then, yeah. Now, technically, this isn't an infinite loop, and I'll explain this using byte, which can only hold -128 to 127. In this case, it'll print all the way up to 127, then finish. And the reason is because when I add 1 to 127, it becomes -128. So, all Java integers wrap around. So, for example, byte b equals 127, b plus plus, then I print b, it becomes -128. Then I print b after I subtract 1 from it, and it goes back up to 127. And this works with int as well. Maximum value, then I add 1, then it becomes the minimum value. That's just some fact that you should know about ints and integers in general. The next exercise, I is initially 5, then 5 is less than 100, so I print 5. Then I becomes 10, and then I becomes 9, prints 9. I becomes 18, then it becomes 17, then it prints 17. Becomes 34, then 33, prints 33. It becomes 66, then 65, prints 65. Then it becomes 130, then 129. Then 129 is not less than 100, so I stop, as shown below. Next exercise. This one looks like a weird for loop. It doesn't have any body, and this one is a print statement in the third slot. So what happens here, first I is 0, then 0 is less than 5, so then I execute semicolon, which does nothing, then I print 0. Then I becomes 1, because I plus plus first prints, then does the increase. Then prints 1, I becomes 2, prints 2, I becomes 3, prints 3, I becomes 4, prints 4, I becomes 5, 5 is not less than 5, so I stop the loop. Next exercise, first I is 0, prints 0, then afterward, none of these ifs are true, so I becomes 1, 1 is less than 20, so prints 1, then I becomes 2, prints 2, I becomes 3, prints 3, then prints 4 after I becomes 4, I becomes 5, prints 5, then I becomes 15 because this is now true, then I becomes 16 because these are false, but then we come across I plus plus, so then it prints 16, I becomes 17, prints 17, I becomes 18, prints 18, I becomes 19, prints 19. Then afterward, I is 19, so I becomes 5. Then print I becomes 6, prints 6. I becomes 7, prints 7. I becomes 8, prints 8. I becomes 9, prints 9. I becomes 10, prints 10. I becomes 11, prints 11. I becomes 12, prints 12. Then I is 12, so I becomes 19. Then I becomes 20 due to I plus plus. 20 is no longer less than 20, so then we're finished with this for loop. Next exercise is to print the integers from 5 to 55 inclusive. So this one, start from 5, go up to 55, add 1 each time, then print it. And there you go. The next one, print the odd integers from 5 to 55. So this one, I still start from 5, go up to 55, add 2 each time, then afterward, print inside the for loop. And it works as shown below. Next, print every integer with a units digit of 7 from 0 to 1,000. We can use the same strategy. Start from 7, go up to 1,000, then add 10 each time to go on to the next number with a units digit of 7. Then afterward, I print inside the loop. As shown below, it works. Next one, print the powers of 2 from 1 to 10,000. So this one, again, same strategy. I start from 1, I go up to 10,000, then I multiply by 2 each time to go to the next power of 2 each time, then I print inside the for loop. And it works. Next one, print the sum of the first 1,000 positive integers. So this one, again, we need a for loop, but we also need an outside variable that keeps track of the sum. So then I go from 1 to 1,000, then sum plus equals I, then I just print sum at the end. As shown below. The next one, same strategy, product of the first 10 integers, basically int product equals 1, then go from 1 to 10, then product times equals I, then I print product. Then it works. And in this exercise, although it may seem similar to the previous exercise, it's not exactly the same. So if I just try product 2 equals 1, then go from 1 to 15 just like the last exercise, then product times equals I, then print product 2, then what happens is I get this result, but it's clearly wrong because doesn't even end in a 0. So then what's wrong with this? Well, we got an integer overflow because the answer is over the maximum value of an integer. So instead we have to use long, which can store larger numbers, and then that'll work. And note that when I do product 2 times equals I, I'm multiplying a long by an int, but it still keeps it as a long.